this presentation, we're going to talk about analyzing data. So look, we did do this lesson, but for some reason or another, I just didn't post it. So I'm re-recording this lesson, cutting out all the announcements because this is going back from April 11th and 12th. In this lesson, you're going to be dealing with types of data, calling out dishonest statistics, which you did through the videos that we watched, dealing with correlation and causation. All right, the challenges in statistics. As I told you guys, is homework heavy. It is center of reading and writing. It is about the technology, however, more so than the computation. It is all about presentation, bringing the valid point home, because in statistics, you try to make a change, and you do that by making your point. You still got to know some math, albeit algebra. All right, data talks. What is it? Which we know what data is. You guys know that data is a number that tells a story. A statistic is using data to inspire change in our lives. All right, so these two precise definitions. Of course, you gotta know both, but one of those who go into statistics gotta know one more so than the other. So those who go into advanced math, you gotta know that mathematics is the techniques to teach, learn, and manage reality by ciphering, counting, measuring, classifying, ordering, inferring, and modeling patterns arising in the environment. So ask yourself this question. Looking at this definition of mathematics, which part or parts is also used in statistics? I'm not going to answer that, but I need for you to figure that out. Statistics is the technique of collecting, organizing, and analyzing data, of course, to interpret the data to make decisions. All right? Make sure you know those definitions well. Don't forget about fathers of probability, Blaise Pascal and Pierre de Fermat. Make sure you know who they are. These fathers did a lot of good and defined probability to what it is today. All right, categorical data, qualitative. It consists of labels and numerical entries. Consists of labels or non-numerical entries that can be separated into different categories. And you guys know this by race, grade, classification, parish, gender, emotions. And you're not doing no computation at all. But when we analyze the data, we will. Numeric data, qualitative. It should be quantitative. So yeah, numeric data, quantitative. So quantitative data consists of numbers that represent counts or measurements. So grades, dollars, people, anything that has a number, that's numeric data. All right, qualitative or quantitative. So remember, qualitative is dealing with categories. Quantitative, quantity, dealing with numbers. So go through these and decide which one is which. Again, we did this already, so you go through it trying to figure that out. data visualization. This is very, 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 very important, especially since we are now doing this and doing our project. So it's a good thing that I reposted this to help you out. All right. So data visualization in the field of statistics is imperative to represent visualizations. In math, we use numbers and symbols to show our work, but in statistics, graphs are equivalent to showing your work. So when you're dealing with data, again, the numbers are all cool and whatnot, but in statistics, you gotta get the graph. You gotta see those visuals. Those visuals are important. They help drive the point across. Because yes, you could tell me your numbers, all this, all that, but if I don't have a visualization, you're not really showing me anything. So histogram, not histograph. I'm making fun of myself because I know in my 1A class I typed in histograph, not histogram. I know one of you guys gave me flank for it, which I'm a good sport. I could take a joke. All right, so histogram is all about frequency, the count. So again, this is mainly best for your quantitative data. So your numerical data, this is where you base want to use this graph. All right. A bar chart is like a histogram, but it's more spaced out used for frequencies for categorical data or qualitative data, not quantitative. Whew. So again, like categories, grade levels, and stuff like that. You see how here I could just look at the categories and how I could, see who did the most and who did the least. So I know the numbers are hard to see, but you get what I'm getting at. All right, so these are the difference. Histogram, which is done in decimals. Bar chart, it's not. So again, this is your histogram. Histogram is used for frequencies for quantitative numerical data, and bar chart is used for qualitative data or categorical data. Box and whiskers. Um, you guys should be very familiar with that because that's what I taught you in using decimals. So this deals with both types of data if you want to deal with it. So this means you could deal with categorical data and numeric data. So in this picture you see, it deals with categories and numerical responses. So see how this is, you got 3 box and whiskers? Those go for each categories. So if I wanted to do box and whisker plots for each grade level based on the number of fights that I had throughout the year, I can do that. Well, that won't be a good example, but grades in particular is a better example. Anyway, so the box and whisker mainly deals with the central tendency, but it does not deal with the mode. The mode is not something that would ever be talked about in the box and whiskers. However, the box and whisker plots focus much more on the medians. And you're going to have 3 different medians. You're going to have the lower 25%, the 50%, and the 75%. All right. And again, box and whiskers can be used for categories, and also could use for quantitative data. But again, this focus on quartiles, and also could be focused on the ranges too. Again, this already have been taught to you already. I'm just going over this for you because when you do your um, project, you have to make sure that you talk about the graphs that you are using and why these graphs are appropriate for your project. All right, pie charts. That is not something that we're going to deal with in Algebra 2. That's going to be more of a statistics thing. A pie chart is a chart that uses pie slices to show relative sizes of data and category of data with percents. So these pieces of the pie, these are all each category, but they have their percentages. So again, this is not something that's going to be used in Algebra 2, but in statistics you will. All right, scatter plots. All right, this is something that we should have a great deal of. So it identifies a possible relationship changes observed in two different sets of variables. So basically, when you're looking at a scatter plot, you're looking to see does all the points form a shape. And remember, when they form a perfect shape, that means that they have a strong relationship, meaning that the correlation is, could be a possible cause and effect. Does not guarantee it, but it's very possible. So when you're doing your project, make sure that you discuss scatter plots well and understand what it means for them to come together. So again, here, you see how these dots are all scattered and how they don't really form a shape? So guess what? This does not have a relationship. Although when you look at it, you see how all these points, they just don't have a shape. So because of it, it looks like it could form a shape, and you see some of the points are on a line, but because not all of them form a perfect shape, you call this a weak relationship. So that means that this relationship is more on chance versus a cause and effect. So that's what I need for you to talk about in your project using scatter plots. And also, scatter plots are used for that correlation relationship. So when you put in your table, you should include these points. All right, a line graph. A line graph in itself is used to display quantitative values over a continuous interval of time. A line graph is most frequently used to show trends and analyze how the data has changed over time. So, when you're doing your project, I need for you to talk about your graph in detail. So, do not just only tell me, what model best fit the situation. Don't tell me just that, but tell me more about what's going on throughout the time and stuff like that. Which, again, you probably are talking about that in your body one. So, but when you're talking about this graph and on your project, I need for you to, talk a little bit about the values throughout the time variable that you have, but also, of course, talk about how the situation happened over time throughout the graph. And one more thing about the line graph. Make sure you talk about the correct models and the incorrect models that would or wouldn't fit the situation. All right. So again, the line graph, once you get into your Google Doc, you're just talking about what happened over time with it. So it's going to sound similar to body one, believe it or not, but it's going to be more shorter because this line graph or whatnot, that's going to fall in your body two. That's when you do your regression analysis. So that's when that's fall all up into it. All right. So one more time, the line graph. Once you get that in there, that's going to fall into body two. That's going to be you talking about the regression models and you talking about what's going on through the time first. Then you're talking about how the models best fit. All right. And again, you got to take this information for yourself and deal with it on your own. Now, if you don't understand this, can't really help you out there. I cannot because we did several examples of this and we do a few in class, not that many, for you to understand this. And you've been doing this year round, believe it or not. You've done this with Ms. Voss. You've done it a little bit in my class in January. All right, dealing with them liars, using statistics to lie. So I'm not going to talk about this because we did this some in class already. So not telling you about it because we know what's up. All right, so take this moment to pause the video and try this out for yourself. This is a fine example of looking at a graph and describing it. But in this example, I'm looking for what's wrong here. But I want to make a note of when you do your project, this is not something that you have to talk about. You want to talk about what's wrong here. So pause the video and see what you could describe about what's wrong in this table graph. All right, pause the video and try it. All right, welcome back. By now, you should have identified what is wrong with this table. So here's my work, my response. I said the scale on the vertical axis on the graph starts at 15,500 and that does not have a break. So that's one thing I said. Another thing I said is this makes it appear that the average cost increase rapidly for the year given. So it makes it look like a big old increase, but if you're looking at this graph, it doesn't look much like an increase. But it appears that way because of how is it presented. The last thing, average cost of tuition. The average cost more than doubled from 2007 to 2011, when it only increased about 1,500. So that's just us identifying it. So nice work so far. If you was able to get those 30 things on your own, good work. All right. So I want you to look at this, pause the video, and figure out what's wrong with it. All right, let's discuss what's wrong with it. But if you not have done so, please do so. Otherwise, let's move on. The scale of the vertical axis has very small increments that are not equal. So let's just look at it. It went from 0.890, 92, 94, and then it started going by twos, then went by ones. See, when you try to present that kind of visual, that's a little bit of a problem. Now, again, when you guys are doing your regression, you don't have to worry about this. So when doing your project, this is not something that you have to worry about. So please don't. Some might believe that the greatest increase in the mean hourly wage occurred from 2011 to 2012, when the greatest increase actually occurred from 2009 to 2010. So, if you figure this out, cool. And that's just pretty much just that. Hopefully this video give you some type of direction. But if not, please just replay and rewind. You got other videos that you could look at. Like I said, I'm not doing a whole reteaching this, that, and the third. That's not happening.